I looked kind of stupid. I was like, oh, she can't hear me. Okay, never mind. I was like, never mind. I'll just go ahead and I think they're eventually going to walk in here. It's okay. Y'all happy it's Friday? It's finally Friday. That wasn't cheesy at all, was it? Oh man, I also did not print the review. So let me pull it up real quick like I did last time. There we go. There we go. Oh, I think I did. Yeah, okay, that's okay. Oh, you'll see everything's like the normal size now. Remember last time it was all zoomed in? Oh my gosh, it was so weird. Okay, so yeah, what we're gonna do, honestly, it's already right past 3 and we only have a few problems to do. We're just gonna go ahead and do them. Grab some paper. We only have those last few problems to do. And then as soon as we're done with them, we're free to go. And then I wanted to announce something right after class. So don't let me just be like, hey, y'all are free to go. Like, remind me. I forget everything, okay? So let's go and do it. I have the review. I can't tell. Let me click right here to make sure this is right. They do that. There we go. I don't know why. What are they looking at themselves? Like, isn't that weird? The angle? Okay. So let me change y'all to just the document camera. And here we go. Okay, so what we did last time was we combined, so it was like different polynomials, right? It was either add or subtract. If there was like a negative near the parenthesis, you distribute it, then combine like terms. Then we converted from scientific into standard and vice versa. We looked at the rules, and I made sure to say that the rules are actually like honestly the most important thing in this whole exam is knowing them, recognizing them, being able to finish them, doing so correctly on your exam. If you do get into a problem, like you can refer to them, you know what I mean? So it's almost like giving you formulas in a way, right? You just got to finish them. We simplified some problems using those rules. I did say that, you know, a set of parentheses with whatever's inside of it, if it's raised to the 0 power, it just immediately turns into 1, right? We did 5A, which was, did we do? No, these are where we're at now, right? It's problem 5 and problem 6. So here we go. This is going to be part 2 of the exam. 3. This is exam 3, right? Exam 3 review. And we could say part 2. Okay. So we did 1 through 4 last time. This is problem 5. The directions, y'all, it just says perform the division. Okay. I always spell perform wrong. Perform the division. Okay, so the first problem is going to be where we pull the greatest common factor, and then we'll notice, hey, things cancel. Okay, I think this problem, I'm looking at it right now, there's 2 terms in the numerator. More than likely, it would be 3 terms, right? So you just pull the GCF from all 3 terms. The second one we're going to do is going to be a long division. I don't have a long division problem on your exam. Those are just, I mean, there's enough homework on it, right? Like, and those are super easy to confuse. And if they cost a lot of points, like that immediately drops you down a letter grade or something. Like, I just don't want to do that, okay? This 5A is similar to what you would see, but this has 2 terms. We'll probably have 3 for sure. It says 12x to the 6th power, and then it's a negative 6x to the 4th divided by 6x to the 4th. Now, I'm just going to say this because it's true. Someone who really does not understand anything we've done, someone who hasn't been to class, someone who hasn't done their homework, there are people who will just instantly, automatically just draw lines through this, right? And be like, boom, they're the same, like they cancel. She said that, they cancel, right? The reason mathematically why you can't do that is because of this operation. Like this is actually acting right now as like one whole thing. And so you can't legally, you know what I mean, mathematically just cancel these two. You actually need to look at the top and see, how can I turn this into where it's multiplication? Because that's where I can cancel and not break any rules. And so what we did was we pulled the greatest common factor out of our numerator. Let me move this little speaker. The greatest common factor out of our numerator, and then you have multiplication, then you can cancel. I'm going to go to the right. I'm looking at the top, y'all. I'm looking at the numbers because I want to know what is the largest number that can divide both of these, right? Greatest common factor. And then when you look at the variables, kind of backwards, it's still the greatest common like variable, but what you do is you just pick the smallest exponent. So looking at my coefficients, the largest number that can divide both of these would be the number 6. Yes, 2 will work. Yes, 3 will work as far as what can divide them, but I want the biggest one. It would be 6. For your variables, what you do is you just pick the one that has the smallest exponent. So it would be x to the 4th. That's the GCF. You don't really stop there though, because what you need to do is actually pull it out and technical lingo. You're going to divide each term by the GCF. So literally, you're going to divide this by the GCF. It's a little quotient, right? Your answer, your quotient goes here. Then you divide this by your GCF, and your answer is going to go right here. Then in the top, all I have is multiplication. As far as this times this, that's when you can cancel, okay? So doing so, I get 12 divided by 6 is 2. Signs are the same, so it's positive. X to the 6th divided by x to the 4th, the quotient rule says keep and subtract. And then 6 divided by 6 would be 1. Signs are different, so that would be a -1. I usually don't like to write ones, but let's kind of see what happens with my variables. X to the 4th divided by x to the 4th. Okay, exact same variable, exact same exponent. Technically what happens is they go to 1. And so I would just have like, you know, -1 times 1. You don't have to write that. I know I usually don't write ones for my coefficients when I do like that division, but because this completely does go away when you do this, I'm sorry, that just looked wrong because it looked like I was talking about that. I'm not. When you do this division right here, these two, the GCF in this term, the 6 and the 6 go to 1. The x4th and the x to the 4th go to 1. That negative, we need to make sure we put here, and that's like a placeholder, right? We have to show that 1. Now, if you notice in my numerator, what I have is 6 times something. I don't care what's inside of the parentheses. It's 6 times that factor, right? Times that set of parentheses. That's multiplication. That means that now what I can do is cancel. That was my whole goal. You just can't do it here. Okay, if something seems too easy in a math class, probably because it is, right? If you just draw lines through it, oh, well, that was easy. Okay, you probably didn't do it right, okay? The final answer just ends up being what's inside of those parentheses, which is 2x squared and a -1, or, you know, 2x squared -1. Yes. So individually, I think in the video, if you watch it or if you were here in class, you'll see I kind of did like each step to the side. Since it's review, I really didn't, but I can. So when I found the GCF, whenever I said we're going to like pull the GCF out of the numerator, the technical right word for that would be divide each thing in your numerator by your GCF. So if you came to the side of your paper, I take this first term and I divide it by my greatest common factor. I get 12 divided by 6 is 2. Signs are the same, so it's positive. And then you apply that exponent rule, that quotient rule right here. You do x to the 6th divided by x to the 4th. What you do is you keep and you subtract. So I get 2x squared. And then like I kind of did all that side work, right? Excuse me. And then the answer I got here, well, that's my quotient. When I divided this by this, that's my quotient. That goes right here. And then do the same thing right here. negative 6x to the fourth. You divide everything by your GCF, but what you pulled out, right? Like what they all had in common, you divide everything by it. So divided by 6 to the fourth. Well, 6 divided by 6 is 1. Signs are different, so it's negative. X to the fourth divided by x to the fourth. When you have the exact same variable and the exact same exponent, those literally just completely cancel. Technically, they go to 1. But if you wanted to see all the work, what you do when you divide variables is you keep your base, right? Just like we did here. Keep your base and you subtract your powers. Okay, so I've got a negative 1. 4 minus 4, isn't that just 0? Oh, hold on. Anything raised to the 0 power just becomes 1, right? Oh, I just get negative 1. Okay, so I just kind of went past like a couple of different steps, but definitely if you need to watch the video, this would be 12.67. We're performing the division and then we did the thing. 12.6 or 7, I want to say, or whenever we do like the long division, and then this is just pull the GCF. So I have videos on there, okay? Just so you definitely get that step down. Especially because the example I'm going to do now is kind of completely different in a way. But like I said, this 5B problem, I don't have one of these on the exam. I think I might have put one on the practice questions just because it is good work, but it's not on the exam, okay? Say we have 2x squared plus 2x plus 20 divided by x plus 6. I think this might be 12.6, which means the other problem would be like a 12.7. So the previous problem would be like a 12.6 problem. I can't just pull a greatest common factor here and see what divides. I mean, if you do notice, they all have 2 in common. They don't have an x in common. So I would just have a 2 that comes out, right? And then when you look on the bottom, there's not even a 2 to cancel. And so the easiest way to know when to do long division or when to do the GCF method is if you have more than 2 terms down here, you have to do long division. Right here, I get that's a coefficient and a variable and an exponent, but that's all one term, right? It's one thing. Here I've got this and I've got this. That's 2 terms. 2 terms in the denominator means do this long process, which is the long division, okay? Okay, so I'm just going to rewrite it. I'm going to write this inside of my box, and then I'm going to divide it by x plus 6. If anything, y'all, I get that I've kind of made the decision not to include a problem. It's difficult in the ways that it's really, really easy to make one little mistake. It's still worth doing because you still have homework over it. And if you haven't finished your homework, like hopefully this kind of reinforces the steps, right? So what we do is we divide, we multiply, we subtract, and then we bring down. So we divide these 2. So we do 2x squared divided by x. 2 divided by 1 is 2. X squared divided by x is x. That's my little quotient, right? That's my little answer that I just got. It gets written, we're going to call this a house. It gets written on top of the house. Because it's x to the first power, it gets written on top of whatever has x to the first power because you're like lining up common things, right? So this 2x gets written right there. After you divide, you multiply this times everything, writing your like terms under where it needs to go. So if we do, you'll notice it's backwards from this, right? If you do 2x times x, 2 times 1 is 2, x times x is x squared. Sorry, those are both positive. So it's a positive 2x squared. Now this is my little product, right? So this is going to get written wherever it needs to under here. You determine where it gets written because it has to match. It got to be like terms. X squared needs to be written under the x squared. Now, y'all, when you do your multiplication, that very first multiplication, needs to be this very first term, wherever you are in the problem, because the goal is that it cancels. If they're not the exact same, they're not going to end up canceling, right? So it's like, okay, great, they're the same. I needed that. Now do this multiplication. Go 2x times 6. We get 2 times 6 is 12. Signs are the same, so that makes them positive. X times no x is still it's just x, because it's like x times 1, right? Now this little product right here is going to get written under its like term. X to the first will get written under an x to the first term. And that's a positive 12x. So we did the division. We did the multiplication. Now we subtract, and then you bring down the next term, right? What I mean by subtract is you change the signs of these two terms here. That was positive. Now it's negative. That was positive. Now it's negative. Bring a red pen, bring a, erase it and change them. Do whatever you got to do. Just make sure you change their signs. Remember I said these needed to cancel? And so the fact that they were the same thing, and then when I change the sign, now they cancel, all my steps are just perfect so far. Those go away. Scoot over here. I've got a positive 2x combined with a negative 2x. Signs are different. You subtract, keep the sign of the larger, keep your variable, keep your exponent. If that's confusing, use your calculator. Just make sure you put the positive number in first. So you would do 2 minus 10. You would notice it's minus 10. I'm sorry, I did it wrong, didn't I? You would do 2 minus 12, and you would notice your answer is minus 10. You've just got to remember, when you add and subtract, your variables stay the same. Okay? Now, we divided, we multiplied, we subtracted, we bring down. And then literally, second verse, same as the first. You redo all of those steps, okay? And what you do is you now take, you see how I took this first thing and I did my division? Well, now I'm here in the problem, right? I've already kind of done a good chunk of this. Now I'm here. Now I take this first thing and I divide it by the first term in my divisor. So we can come over here. We can do negative 10x divided by, that's an x. What I get is 10 divided by 1 is 10. Signs are different, so it's negative. X divided by x, well, becomes like 1 minus 1. Like it gets to the x to the 0, like it just goes to 1, right? It cancels. So this little product right here, because there's no variable, is going to get written on top of our house above the term that has no variable, which would just be right here, right? And that's a negative 10. I did my division. Now I actually take this quotient that I got from my division and I multiply it individually to that binomial out here, to each term. So I would do negative 10 times x. Do you notice how this, like these first two steps, it's kind of like undoing something and then doing it again, right? Because I divided by x here and I got negative 10. Well, now I'm going to multiply by x here and get back to that numerator, 10 times 1 is 10. Signs are different, so it's negative. No x times x is still just x, right? This product goes underneath here. Sorry, I almost forgot my sign. It's very important to have your sign. Did you see how I said here these needed to be exactly the same? So when we subtracted, they canceled. Right here, look, exactly the same. That's good, because I know that when I get to the step I need to subtract, they're going to end up canceling. I'm not done yet, because I need to do this negative 10 times the 6. I already did it times the x. Now I need to do it times the 6. So if I do negative 10 times 6, I get 10 times 6 is 60. Signs are different, so it's negative. This product, here I line things up, right? Like terms, there's no variable. It's going to go right under here where there's no variable. Don't forget that if your sign was a negative, I divided, I multiplied, now I subtract. And what I mean by subtract, you change their signs, right? Was negative, now it's positive. Was negative, now it's positive. Which is great, because I need these to cancel And you notice how those are the exact same thing with different signs? That means they canceled. So great, that's exactly what I wanted to happen. Scooch right here, I got two values that are both positive, which means I just add them and I keep the fact that they're positive, right? $20 in the bank, $60 in the bank. I got $80 in the bank. Our next step would be to bring down, right? I know, like, they couldn't make more noise, could they? Our next step would be to bring down. Divide, multiply, we brought down. Divide, multiply. There's nothing else to bring down, so that's it. What you have here is a remainder. If it's 0, technically you don't really have a remainder, right? Because it all went in equally. But here we do have a remainder. If you have a remainder, the way you write it, this is our quotient. You write this, the quotient we have right here on top of our house, and then we add our remainder over our divisor. Sometimes in the homework, even if you do get 0, they still might want it in this form. So you would just put 0 divided by, right? If you do that math, whatever your variable is, you'll end up getting 0. So it tells you your remainder is 0. So that's how you do the long division, okay? Now we have 6A, B, and C, and that's it. Okay. So for problem 6, it just says multiply the following. So our rule is multiply. Now, what it doesn't say is to combine like terms or, simplify as much as needed. That's implied, y'all. Okay. If you do some multiplication, because there is a problem in here that you're probably gonna have a bunch of terms, you wouldn't just do that multiplication and be like, I'm done. You actually need to combine what can be combined. Okay. So that would be implied that you understand that. For A, we have in parentheses 3x plus 2, close, open, 3x minus 2. Now, there will be some of y'all that automatically sees what this is and understands this form and can immediately jump into the answer and not have to do the FOIL and combine, okay? It's not expected for you to know that, but if you do, it's okay just to state the answer, right? Because this would be a difference of squares. Same exact terms, different signs. All you have to do is square this and square that and you're done, right? But there's nothing wrong with foiling it and then canceling what can be canceled. FOIL means take your first two terms. This is the first in that set of parentheses. And then this is the first term in that set of parentheses, right? That's why I'm saying the first. Take the first two terms. 3 times 3 is 9. Signs are the same, so it's positive. X times X is keep and add. And then in FOIL, you have outer. Your O is outer. These would be the outer terms. I've got 4 total terms. These are your outside ones. So you do this. Just remember that it's all multiplication, okay? Like, don't accidentally think that that is a -2 from this term. They're not even like terms, right? Do this multiplication. 3 times 2 is 6. Signs are different, so it's negative. X times no X is just X. Technically, it's like X times 1, right? You just get X. Then first outer, right? Now it says inner. With these 4 terms, those right there would be your inside terms, right? The inner ones. Multiply these 2 terms. You get 2 times 3 is 6. Signs are the same, so it's positive. No X times X is X. And then the last letter in our acronym is L for last. What that means is if you look at these 2 terms, that's the first term. This is the last term in this parenthesis, right? In this binomial right here. This is the first term. This is the last term. So it's saying multiply these 2 last terms together. You would get 2 times 2 is 4. Signs are different, so it's negative. This wouldn't be your final complete answer. So even if the directions just say multiply, you need to be able to recognize, hey, there's more math that I can do here to simplify it, right? And so what you would do is notice that right there, those can cancel, right? They're additive inverses, exact same numbers, exact same exponents. I'm sorry, I don't know why I said exponents. I got distracted by my screen right here. Exact same numbers, exact same variables, but they have different signs. Okay, if you literally just look at it like money, I've got $6 in the bank and I subtract $6 from the bank, like they go away. The only thing left is your 9x squared and your -4. That's why I said, if you recognize this as a difference of squares, just take one side, square this, you get 9x squared, square this, you get 4. You just put a negative sign in between them. You put a minus sign in between them because it's called a difference of squares. Okay, let's do B. Okay, so on the outside of these parentheses, I have 2x cubed and then open. The inside is 3x cubed, a -2x, and a -1. And so what I would want you to recognize in this problem is that we have a monomial multiplying a trinomial. More importantly, I've got a term, I've got something touching a parenthesis, which implies distribution, right? That implies multiplication. So what we need to do is to actually distribute that to each and every term, doing multiplication each time. So we would do this right here, and you would get 2 times 3 is 6. Signs are the same, so it's positive. And then x cubed times x cubed, right? That's multiplying variables. When you multiply variables, you keep the base and you add the powers. Keep and add. I get x to the 6th. And then you also distribute, right? Just like Amazon, everybody's going to get their package. When you distribute a number or a term into a set of parentheses, everybody's going to get multiplied, okay? So we're going to do that. You get 2 times 2 is 4. Those signs are different, so it makes it negative. And then x cubed times x, keep and add. So x to the 4th. And then you also do multiplication here, y'all. Even though that does not have a variable, it doesn't mean like, oh, I do multiplication until right here, there I add or I subtract. No, it's all multiplication, okay? 2 times 1 is 2. Signs are different, so it's negative. Hold on. My another graduate assistant left her keys here. She just asked if I was still here. I just want to make her comfortable and know she can come. Yes, I am. I'm teaching right now, exclamation point. I don't want her to walk over here and it be a time I'm not here, so she needs to come right now. 2 times 1 is 2. Signs are different, so it's negative. Y'all, x cubed times no x cubed, technically you're multiplying it to a 1, or you can just think that it was a part of my original multiplication. It's going to be a part of my product. There just wasn't another variable with an exponent that caused me to use the product rule and that exponent be added to something else, okay? That's literally your answer. And I knew that was my answer because even though I, just created all these new terms, I don't have anything that's alike, right? That's x to the 6th, that's x to the 4th, that's x cubed. That's the only thing I'm looking at when I'm looking for like terms, and none of them are alike. So you're done there. Okay, so I'm going to turn it this way just because I see it's a binomial times a trinomial, and I feel like I might, need it more in a landscape format right here. This is 6C. Okay, so I've got a binomial on the left-hand side. In parentheses is x plus 4. And then open new parentheses. Those two parentheses touching, that's what tells me I'm multiplying. If this was not in parentheses, only that 4 would be touching, right? So only the 4 would get distributed. That's why it's important when you see parentheses and parentheses, literally, all that means is every single thing in your left-hand side is going to multiply individually to every single thing in your right-hand side, okay? Your right-hand side, that parenthesis says 3x cubed. And then we have a positive 2x and a positive 3. I'm telling you right now, this problem isn't even going to be that hard, even if it looks like it might be a little long. And the reason why I'm saying that, those are all plus signs, right? So I'm not going to have to worry about signs are different. It's negative. And then when I combine, subtract and keep, I mean, this is all addition, basically. I'm going to have to multiply each thing, but then I'm just kind of adding stuff together if they're alike. Okay. So literally everything on the left-hand side multiplied by everything over here. So take your x and do this multiplication. That's a 1. 1 times 3. I'm going to do my answer right here. Okay, just because I know it's going to kind of be a lot of different terms. I don't want to run out and, you know what I mean, like start sliding down the page. 1 times 3. I circled this so that you would know that's where I went. Is 3. Signs are the same, so it's positive. X times x cubed is keep and add. I get x to the 4th. Now, I'm still working on my x because it hasn't multiplied everything yet, right? Come here. 1 times 2 is 2. Sides are the same, so it's positive. X times x, keep and add. I get x squared. Lastly, still multiplication, okay? 1 times 3 is 3. Signs are the same, so it's positive. X times no x is just still x. Or like I was fixing to do, which is kind of what I do in my head, is just x times 3. That's the same thing as saying 3 times x. That's just 3x, right? Now let's take this second term in the binomial right here, and we're going to multiply that 4 to everything. So right here, what I would get first is 4 times 3 is 12. Signs are the same, so it's positive. And then no x times x cubed, it's still just x cubed, right? Because I'm just not multiplying it to another variable. Now do that multiplication. That little arrow, bumpy rainbow thing got a little crazy, got away from me. 4 times 2 is 8. Signs are the same, so it's a positive 8. No x times x is just x. I didn't want to cross out stuff, and I totally did. Hope that doesn't confuse you. Oh, that's a little line doing this to show y'all we're multiplying, right? 4 times 3 is 12. Signs are the same, so it's positive. No x times no x is no x. Like there's no x in that original multiplication, so it's not going to be a part of my product. 1 doesn't just magically appear. Okay. So now I've gotten to a point where I said in a problem, if you do the multiplication, don't just think, oh, I'm done. Actually look and make sure, are you done, or are there things that are alike? And what I mean by alike is same variable, same exponent. Start here and work your way to the right. Here, I've got a 3x to the 4th. So if I look, nothing else has, the only thing I care about is that exponent. That's it. I can worry about the coefficients and the numbers later. I just need to identify, does anything else have a 4th, like x raised to the 4th exponent? It doesn't. So you just bring it down. That literally just means it can't get combined with anything, right? It can't be added or subtracted. If you want to cross it out, you can cross it out. Do whatever you need to do. Go ahead and do a little line through it, and then I go to the next term. Sorry for drawing a line through this, but that is actually a square. Now I have a positive 2x squared. Now look, if there's anything else that's squared, I don't have anything else that's squared. So I would just write plus 2x squared. I'm done with that. Scoot over. Positive 3x. So that's a 1 as an exponent. And when I look, if anything else has a 1 as an exponent, this does. So that means I'm doing plus 3 plus 8. Signs are the same. So I would add. I get 11. Keep your variable, keep your exponent, mark them out. So now I notice that this is an x cubed. It's like, hold on, I usually go in order and this one's not in order. So let me just finish what I'm doing here, and then I'll just need to rewrite it in order, right? I probably wouldn't look for that on an exam, but if it explicitly stated, write it in descending order, put them in order, right? 4, 3, 2, 1, you go down. Nothing else has an x cubed though, so just write positive 12x cubed plus 12, little number by itself, no variable. Nothing else like it, right, plus 12. Now this would need to go here in order to have 4, 3, 2, 1, none, right? So the completely correct and proper answer, not only combining your like terms and doing your multiplication, right? But also putting it in descending order would be 3x to the 4th plus 12x cubed plus 2x squared plus 11x plus 12. Does that make sense? Yeah. And sometimes even doing all of this and then getting here and then finding, it might not even stand out that that one's out of order. You know what I mean? So that's going to be super important. This is a small, minute detail. Okay. Okay. So let me end this by doing this.